What is the coefficient of I in the first vector? 2, j is 1, k is 3. For the second vector, coefficient of I is minus 1, j is 2, k is plus 1. How many box products are there? So this is equal to ABC plus ABC is nothing but 2 times the box product of ABC. If the box product of vector AB, comma vector AC, comma vector AD is equal to 0, then they are coplanar. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss very important problems for 3 marks in vectors. In the previous class we have discussed regarding 1 mark, 2 marks and few 3 marks questions. Today particularly I will discuss only 3 marks very important questions in this vector algebra. Now let us right away move to the first problem. These are very important type for the point of examination. So definitely we will get one question from this type, that is for 3 marks. 3 vectors, vector A, vector B and vector C are unit vectors, satisfies the condition A plus B plus C is equal to 0. Then find A dot B plus B dot C plus C dot A. Very important concept. So what is given? Given that A, B, C are unit vectors. Given vector A, vector B and vector C are unit vector means length of A is equal to 1, length of B is also equal to 1, length of C is also equal to 1. Further, second condition satisfies the condition A plus B plus C is equal to 0. Now, just take dot product on both sides for this A plus B. So, taking dot product for A plus B plus C on both sides, we can write A plus B plus C dot A plus B plus C is equal to 0 into any number is 0. Or you can also write like this, squaring on both sides, A plus B plus C whole square is equal to 0. So that is nothing but A plus B plus C dot A plus B plus C is equal to 0. Just multiply it. So this is of the form A plus B plus C whole square we can use A square plus B square plus C square plus 2AB plus 2BC plus 2CA. That is nothing but length of A square plus length of vector B square plus length of vector C square plus 2 times vector A dot B plus 2 times vector B dot C plus 2 times vector C dot A is equal to 0. Now just substitute the value of length of A, length of B, length of C as 1, 1, 1. So you will get 1 square plus 1 square plus 1 square plus 2 times, you can take 2 common factor, A dot B plus B dot C plus C dot A is equal to 0. Now length of that is 1 square is 1 plus 1 plus 1 plus 2 into A dot B plus B dot C plus C dot A is equal to 0. Now 1 plus 1 plus 1 is nothing but 3 plus 2 times A dot B plus B dot C plus C dot A is equal to 0. Right. Now, so transfer this. Therefore, 2 times A dot B plus B dot C plus C dot A is equal to minus 3. So, therefore, the required answer is therefore A dot B plus vector B dot C plus vector C dot A is equal to minus 3 divided by 2. Minus 3 divided by 2, very important problem. Sometimes they may also ask find mu. Mu is nothing but A dot B plus B dot C and C dot A in the given problem. So this is how we are going to solve. Similarly, so the same problem they may ask if 3 vectors A, B, C instead of unit vectors they may give the value. Say for example, if length of A is equal to, length of A is 2, length of B is equal to 3 and length of C is equal to 4. Then in this case also you can find mu is equal to A dot B plus B dot C plus C dot A is equal to minus of A square 4 plus B square 3 square is 9 plus 4 square is 16. 16 plus 4, 29. 16 plus 4 is 20 plus 9 is 29. Minus of 29 divided by 2 for this problem. So they may ask like this also, right? So definitely we'll expect either this or this question for the point of examination for 3 marks. Now move on to the next problem. This is also important type problem. What is the problem given? If length of a plus b is equal to length of a minus b, prove that a and b are perpendicular. So you know the condition for two vectors to be perpendicular. If a dot b is equal to 0, then the two vectors are said to be perpendicular to each other. Now what is given? Length of a plus b is equal to length of a minus b. Just prove that a dot b is equal to 0. For this, squaring on both sides. Now what is given? Given that length of a plus b vector is equal to modulus of a minus b vector, right? Now just square it, squaring on both sides. So what happens? This is nothing but length of a plus b whole square is equal to length of a minus b whole the square. Now this is nothing but a plus b whole square length is nothing but a plus b dot a plus b. What is this equal to? This is nothing but length of a square plus length of b square plus 2 times a dot b, right? So we can write this is nothing but length of a square plus length of vector b square plus 2 times a dot b vector. Similarly, for the second, a minus b whole square is also equal to length of a square plus length of b square minus 2 times a dot b vector. Just bring all the right hand side terms to the left hand side, then this will be the same. Length of a square plus length of vector b square plus 2 times a dot b. Transfer this minus length of a square minus length of vector b square minus becomes plus 2 times a dot b is equal to 0. Now cancel that term. So plus a square mod minus a square mod gets cancelled, plus b square mod minus b square gets cancelled, and what is left over is 2 times a dot b plus 2 times a dot b is nothing but 4 times a dot b vector is equal to 0. So therefore only a dot b vector a dot b is equal to 0 divided by 4 is equal to 0. What you will got? A dot b is equal to 0. Since a dot b vector is equal to 0, therefore vector a is perpendicular to vector b. Since a dot b is equal to 0, a dot b is equal to 0, therefore vector a is perpendicular to vector b. That's it. Two vectors a and b are perpendicular. Very important problem for 3 marks. Now move on to the next type problem. So find the volume of a parallelepiped whose coterminous edges are 2i plus j plus 3k, minus I plus 2j plus k, and 3i plus j plus 2k. So in the previous class we have discussed regarding scalar triple product or box product. So just find out the box product of these 3 vectors, that will give the value of a volume of a parallelepiped. Now what is given here? Given vector a is equal to 2i plus j plus 3k. This is given. Vector b is equal to minus I plus 2j plus k vector, and vector c is equal to 3i plus j plus 2k vector. Now volume of the parallelepiped, volume V is equal to determinant. Just write down the coefficients of I, j and k in these 3 vectors. What is the coefficient of I in the first vector? 2, j is 1, k is 3. For the second vector, coefficient of I is minus 1, j is 2, k is plus 1. For the third vector, coefficient of I is 3, j is 1, k is equal to 2. Just find out this value. So expand with respect to first row. So that's equal to 2 into this row and column is gone, 4 minus 1 into this row and column is deleted, minus 1 2s are 2 minus 3 plus 3 into this row and column is gone, minus 1 minus 6. That's equal to 2 into 3 minus 1 into minus 5 plus 3 into minus 7. So this will give the answer. See here, just write down the coefficients of I, j, k for these 3 vectors. 2, 1, 3, minus 1, 2, 1, 3, 1 and 2. Simplify with respect to, expand with respect to first row. 2 into 2 2s are 4, minus 1. Minus 1 into minus 2, minus 3, plus 3 into minus 1, minus 6. 4 minus 1 is 3, minus 2 minus 1, minus 3 is minus 5. 3 into minus 6, minus 7, minus 6, minus 1 is minus 7. 2 6 are 8, minus into minus plus 5, 7 3s are 21. So, 6 plus 5 is 11 minus 21. 11 minus 21 is nothing but minus 10. So, therefore, the volume of this parallelepiped is equal to, volume of the parallelepiped is minus 10 units, cubic centimeters. Negative sign indicates it is decreasing. That's it. Okay, right. This is nothing but 11 minus 21. That's equal to minus 10. Now, let's move on to the next problem. This is very important problem indeed. What is given? Prove that the box product of vector a plus b, comma b plus c, comma c plus a is equal to 2 times the box product of a, b, c. Very important question. You may expect this for your final examination for 3 marks. Now, let us take LHS first. LHS, box product of vector a plus b, comma b plus c, comma c plus a. Now, let us assume this as capital A, capital B, capital C. Now, you know what is the box product for ABC? Is nothing but A dot B cross C, right? Box product of vector ABC is A dot B cross C. So, what is here? A plus B is A. What is B? B plus C. What is C? C plus A. So, if you apply the same concept, A, vector A plus B dot B cross C. B cross C is nothing but vector B plus C cross C is nothing but C plus A. This is very important step. That's it. See, A dot B cross C, A dot B cross C, B plus C cross C. Just simplify these two values. So, this A plus B dot as it is, simplify this. B cross C plus B cross A plus again C cross C plus C cross A. So, this is equal to vector A plus B dot B cross C as it is, B cross A is also as it is, C cross C, since according to the property of determinant, if 2 rows 2 columns are same, then the value of a determinant is 0. C cross C is equal to 0 here. So, this is 0 plus C cross A as it is, right? Hope you followed. See here, just write this as vector A, B, C is nothing, box product of A, B, C is A dot B cross C. A dot B cross C, A plus B dot B plus C cross C plus A, multiply B into C, B cross A, C cross A and C cross A. Since C cross C is equal to 0, we will get A plus B dot B cross C plus B cross A plus C cross A. Just I will write it in the next page. That's equal to A plus B, vector A plus B dot, what is left over is B cross C plus B cross A plus C cross A. Now, just apply A dot, first multiply this, A dot all these 3 vectors, A dot vector B cross C plus A dot vector B cross A plus A dot C cross A. Similarly, you take B, B dot all these 3 vectors, similarly multiply with B, B dot B cross C vector plus B dot B cross A vector plus same B dot C cross A vector, right? So, you know A dot B cross C, A dot B cross C is nothing but box product of vector A, B, C plus A dot B cross A is 0, A dot C cross A is also equal to 0, B dot B cross A is also equal to 0, B dot B cross A is also equal to 0. Again, B dot C cross A is nothing but the box product of A, B and C. So, how many box products are there? So, here this is one box product A, B, C plus another box product A, B, C. So, how many box products are there? So, this is equal to ABC plus ABC is nothing but 2 times the box product of ABC. So therefore the required answer is 2 times the box product of A, B, C, which is the RHS. Very simple. Since here these values, since A dot C cross A is equal to 0, again B dot B cross A is 0, B dot B cross C is also, if 2 rows 2 columns are same, then the value is equal to 0. So remaining are ABC plus ABC, 2 times the box product of ABC. Hope you followed. Very important problem. There is one more problem like this, that is also very important. That is, prove that the vector A comma B comma vector C plus D is equal to box product of ABC plus box product of ABD. This is also a very simple problem. Take LHS. What is LHS? Vector A comma B comma C plus D box product. So this is also same as that of, let us assume this, capital A, capital B and capital C. What is the box product of capital A, B, C here? A dot B cross C. What is A? A is vector A, B is vector B, C is nothing but C plus D vector. So A dot B. What is B? B is nothing but vector B cross C. C is equal to C plus D vector. So this is A dot as it is multiplied B cross C plus B cross D vector. Right. Now what is this equal to? If I apply, if you just multiply it, put dot product for this. So this is A dot B cross C plus again A dot B cross D. Now observe carefully, what is this equal to? A dot B cross C is nothing but box product of ABC, box product of ABC plus A dot B cross C. A dot B cross C is again nothing but box product of vector A, B and vector D. So which is the required RHS. See, show what is to prove? Box product of ABC plus box product of ABD. This is also important for 3 marks. You may also expect this question, this or that for the point of examination. Very important for 3 marks. Hope you followed. Right. Now there is one more problem you expect. Suppose if 4 lines are given, 4 vectors are given, verify that the given vectors are coplanar, or if 4 vectors are given and if it satisfies the condition that it is coplanar, find the value of x or lambda or k. Now let us take one small example on that. Show that the 4 points with position vectors, vector A is equal to 4i plus 8j plus 12k, vector B is equal to 2i plus 4j plus 6k, right. Vector C is equal to 3i plus 5j plus 4k, right. And vector D is equal to 5i 8j plus 5k are coplanar, right. Very important for 3 marks. If these vectors are coplanar, then AB dot vector AC cross AD is equal to 0. If dot product, scalar triple product of AB dot AC cross AD is equal to 0, then the 3 vectors are coplanar. Okay. Now just find out the position vectors of vector AB, then AC and AB. AB is nothing but vector B minus A. Subtract these two. So this 2 will give the vector AB. 2 minus 4 is minus 2i. 4 minus 8 is minus 4j. Again 6 minus 12 is minus 6k. Vector AB. Now similarly vector AC. AC is nothing but vector C minus A. 3i minus 4 is minus I. 5 minus 8 is minus 3j. Again 4 minus 12 is minus 8k. Now the last one, vector D minus A is nothing but vector AD. Position vector of AD. 5i minus 4i is 1i. 8j minus 8j is minus 0j. Again 5 minus 12 is minus 7k. That's it. Just by knowing this, find out the box product of vector AB dot vector AC cross vector AD. So what is this equal to? This is nothing but the determinant coefficient of ijk, minus 2, minus 1, this is plus 1, minus 1, minus 2, plus 1, coefficient of j is minus 4, then minus 3 and 0. Coefficient of k is minus 6, minus 8 and minus 7. Simplify this. If this is equal to 0, then the 4 points are said to be coplanar. Okay. Now simplify this. This is plus, minus and plus. Expand with respect to first row. So that's equal to minus 2 into 7 3s are 21, minus into minus plus, 0 into number is 0, minus into minus plus 4. This row is column is gone. 7 1s are 7, minus into minus plus, 1 8s are 8, minus 6 into this is gone, 1 into 0 0, minus into minus plus 3. So that's equal to minus 2 into 21 plus 4 into 7 plus 18 is 15, minus 6 into plus 3. This is minus 12 to 21 into 2 is 42, 15 4s are 60, minus 6 3s are 18. This is 60 minus 42 minus 18 is minus 60. What is 60 minus 60? Is equal to 0. That means the 4 points, therefore, the 4 points are coplanar. Very important for 3 marks. So, to verify the coplanarity, just find out the box product of AB dot vector AB dot AC cross AD. That is box product of vector AB, AC and AD. So, if the box product of vector AB, comma vector AC, comma vector AD is equal to 0, then they are coplanar. Very important concept. Hope you followed. So these are few problems for 3 marks for your final examination. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.